All right, I think we are ready to go, everyone. So welcome to the second live stream. Feel free to let me know in the chat if the sound isn't working or isn't working properly for you. I wasn't able to preview anything tonight. And as always, if you do have some questions that you want to take care of tonight, email them to mathquestionshelp@gmail.com. So I'm going to start with a couple questions from my business math class. That is Math 114. So I've had a request to do a couple of the questions from the practice test, specifically numbers 1D, 1F, and number 3. So let's start with 1D. 1D is asking us to expand and simplify this expression. Okay, so in blue, I'm just going to probably consider, like, if I want to just go and do a straight through expansion, I need to multiply this 2.1x to all the other terms. And in green, I need to multiply this negative 0.3y to all of my other terms as well. So I'm going to end up getting 6 different terms, 3 from the 2.1x and 3 from the 0.3y. Oh, Jamie, you're killing me tonight. All right, so let's go through and multiply that 2.1x through, and I'll come back and I will see if I can harass Mr. Mitchell. So 2.1x times 1 gives me 2.1x. I'm going to grab a calculator here because I can't do decimal multiplications in my brain. So we got 2.1 times 5.2. It's going to give me 10.92. And I'm going to look at the variable portion. So x times x is going to give me an x squared. And then third here is this 2.1 times 0.7. So let's do that. 2.1 times 0.7. It's going to give me a negative 1.47. And then we'll take a peek at the variable portion. So x times y gives me an xy. So there's our first 3 terms represented by our blue arcs. Next, I want to get at the 3 portions represented by the green arcs. So 0.3y times 1. And then 0.3y times 5.2x. So 0.3 times 5.2. It's going to give me a negative 1.56. And let's look at the variable portions. I have a y and an x. I'm just going to put them in order like this, an xy. And finally, 0.3 times 0.7. That's going to give us positive 0.21. And looking at the variable portions, I'm going to get a y squared. So those would be the 3 pieces that correspond with the green arcs that we see. So if we expand this way, we just have one last step, and that is to simplify this expression. So maybe I'll put the squared portions first, so 10.92x squared and my 0.21y squared. There are no other terms that I can add or subtract from these ones. I have a couple xy's that I might be able to simplify. So I'm looking at kind of these ones here, look like they might be able to simplify. I don't think the single x's or the single y's, we're going to be able to simplify those. So we're just going to copy those down. Oops. So I just need to subtract 1.56 from negative 1.47. And that's going to give us negative 3.03 xy's. So here's one possibility on how to expand out this particular expression in 1D. If you find this to be a little bit confusing and it's not super easy to follow this one, you could always try a lattice method as well. So we saw in class that we could take each one of these terms and we could write it out in a lattice kind of way. So I have a 1, a 5.2x, and a negative 0.7y. And each box that I get here, each empty box in the lattice method, it represents a multiplication of two terms. So for example, this box represents the multiplication of 2.1x times 1. This one would be our negative 0.3y times 1. And I can go through and fill in all of these boxes, and they should correspond with those 6 terms that we had up top. So here would be our 10.92x squared. Our negative 1.47xy, and so on and so on. Okay, and from here you can kind of check through the different boxes inside of the array to see if you can add or subtract anything. So our 10.92x squared, we wouldn't be able to add that with any of these other terms, so that one's done. We have a 2.1x, we have a 0.21y squared, a negative 0.3y, and we have these two xy terms that we can subtract to get negative 3.03xy. So here's just an alternate way to work through this one using a different looking method. All right, so the true reason comes out why I do live streams and I don't have extra office hours is because I just really like wine and I can't bring wine to office hours. All right, so Keaton, that was a couple different ways to tackle 1D. So I want to go back and look at 1F for you, and then I can work on 1A as well. So here's 1F. So 1F is dealing with craps, which is a casino game, actually one of my favorite casino games. What happens is you roll the dice, and you're going to bet on what outcomes are rolled on those particular pair of dice. So let's say, for example, we roll a number 8. 8 gives us a 7-6 payout. Okay, so that means for every $6 that I bet, if I roll the number 8, then I'm going to win $7. So let's say, for example, I am going to lay down a $90 bet on the number 8. The question here is, how much would I win if I do that? Okay, so essentially we're looking for a scale factor. So if I can figure out 6 times what is equal to 90, that's going to help me figure out the other side here. Okay, so it turns out, and getting called out here on the chat, yeah, with the love of wine, yeah. So it turns out our scale factor here is 15. So if I take 7, multiply it by 15, I'm going to figure out my payout on this particular bet. So let's take 7, multiply by 15. It's going to give me 105. Okay, so if that 8 does come, I should win $105. Okay, so those of you that might just be tuning in, if you do have some questions, you can email them to mathquestionshelp@gmail.com, and I will work through them as they come in. I'm just kind of working through some of the practice questions from our business math 114 practice test. 1A looks like, yeah, this one's kind of fun, so give me like 3 hours here to write down the question. Okay, so 1A is just a straight up evaluation here. Using our order of operations. So let's see. What I typically do is I try to look for the pieces that are all held together by multiplication and division. So for example, all of these pieces here are held together with multiplication. And these pieces over here are also going to be held together with multiplication. Let me know if the crickets are a little annoying and I will move them. I actually own a tarantula, and tarantulas need live food. So I always have crickets. It always sounds like I'm always camping in my office here at home. Hey, good to see you, Paul and Michaela. Thanks for tuning in. If you do have any questions, send them over to that email account, mathquestionshelp@gmail.com. So if there are any specific questions on the test that you do want to go over, just let me know. Well, I'm definitely not going to pull the tarantula out. That's for damn sure. She's a little skittish. She doesn't like anyone getting near her personal space. But I might be able to move the computer over there if she's out and about and not hiding. Yeah, you might be able to see her tonight. But I have to move my surface. So maybe let me work through this question and then I'll maybe see if I can lift you guys up there for a quick peek if you want. Okay, so let's start working maybe in the brackets of this first underline piece. So -4 cubed, that's going to be -4 times -4, which is 16 times -4, that's -64. And then we're going to multiply that by 3. And then we're going to need to multiply by whatever the hell we get in here squared. So what do we got in here? We got 6 divided by 4 minus 3. So 6 divided by 4, what is that? Let's get that as a decimal. 6 divided by 4 is 1.5. And if we subtract 3 from that, this should give me a -1.5 squared here. Okay, so I'm going to finish up this. I'm just going to type this right into my calculator and get a value for this. So what do we got? -64 times 3 times -1.5 squared. So I get negative 432 for that first underlined blue piece. And then we still have this subtraction of 5 and then this addition of root 37 times ln 3. Okay, so make sure you can get that negative 432. Let me know if I've done anything wrong on that bit. These are pretty easy to get overloaded with. Okay, so I think next up we have some multiplication over here that we should deal with. So let's bust out the calculator again. So root 37 times ln of 3. So I get a pretty awful decimal number. 6, oops. Just gonna go 2 decimal places here, 6.68. All right, so I should now be able to just finish up this addition. Negative 432 minus 5 and our 6.68. So I got negative 430.32. I hope that's water. Yeah, I do have some water here too, I promise. It's important to keep hydrated while you're drinking. All right, so let's see. I'm not exactly how nicely the quality is going to be for the spider here, but hopefully you can get a little peek. And that is a Mexican red knee tarantula, if you could see it. And I do have a second spider. I do have a black widow too, but those are pretty common around here, so not maybe as exciting as the tarantula. Phone calculators on the test? No, absolutely not. So for the test, you'll have to use your... I don't have my my business calculator here, but you'll need your business calculator or another non-programmable scientific calculator. What type of wine? It's a Pinot Gris. I can't remember where it's from though, but I got it for my birthday. And it's very tasty. All right, so I had a request from Keaton to work through question number 3 from this test as well. So question number 3 has to deal with the supply and demand for computers. So they're given by this particular question. And our price is in hundreds of dollars and the quantity is in thousands of computers. So part A looks like it's asking us to find the equilibrium point. And then just trying to interpret what that point means. So let's see. I guess we can go with just a straight up substitution by the looks of it. I can actually take this first equation and just sub that in right here. So my second equation, Q equals 20 minus 1.5p. But I also know that Q is equal to 2.5p. So that's kind of nice. That sets up the substitution pretty easily. I'm going to add 1.5p to both sides. So over here I'll get 3, I'll get 4p is equal to 20. And then if we divide through by 4, we should get p is equal to 5. once I know P is equal to 5, I can use that number back in either of these original ones. So maybe in the supply curve, I can say, well, Q is equal to 2.5P, which is 2.5 times 5. And that is what? 1, 2, so that'll be 10, 12.5. Okay, so there are our equilibrium values. So I just need to go back to the question here to figure out what Q and P are in units. So Q is thousands of computers, so we're going to make 12,500 computers. It's going to be the quantity of computers in our economy. And we have prices in hundreds of dollars. So the price per computer is going to be $500. Okay, so that's what our equilibrium point is telling us in this particular case. Okay, so part B is asking us if the price is set to 550, are we going to end up with a shortage or a surplus of computers? So let's take a look and see what the interaction of our supply and demand curves would give us. Okay, so currently right now we're sitting at a quantity of 12.5 with a price of 5. This is a p-axis, q-axis. And this question is asking us to interpret this value up here. So what happens if I set my price to $550? That's going to be a little bit more. Actually, it's going to be 5.5 according to the diagram that I wrote. But the idea here is that the price is going to increase a little bit, and we want to interpret what's happening with our supply and demand curves, with the quantity. Okay, so let's see if I can make some kind of judgment call here. If the equilibrium price is 500 and it goes up to 550, it looks like our demand is going to decrease a little bit. So our consumers are not going to want to buy as many computers because the price is a little bit higher. However, we're probably going to see more computers enter into the market because our producer is going to want to produce more computers at this higher price. So what I'll do is I'll try to highlight which is which. So looking at our supply curve, this intersection point, here's our equilibrium value. The quantity that my producer wants to make is going to be higher than the equilibrium value. And that's because they're going to be able to sell these computers for $550. They want to produce more in the long run. And this intersection point here of the 5.5 with the demand curve is showing us that our consumers aren't necessarily going to want to go out and buy more. So they're going to be consuming fewer computers because of that increased price. So I think either one of those here is going to be kind of a nice summary statement here. So kind of one of two things could happen. Our producers definitely want to produce more. But our consumers want to consume less. This means what we're going to see is an excess of computers in our economy, or a surplus according to the wording of this question. It does ask what's going to happen in the long run. Probably what's going to happen in the long run in this case, if we have a surplus, is we'll start to see the prices fall back down towards our equilibrium price. There's going to be so many computers in the market that the only kind of natural thing to do is for that price to come down. Okay, so you're asking about P was the quantity. P is always given as the price. So in our original questions here, in our original supply and demand, the capital Q is always going to be quantity, and the capital P is always going to be the price of whatever item we're working with. In this case, it was the computers. Okay, so hopefully that kind of made sense for you for part B. And is there one more? Oh yeah, so the last one is kind of a shock, and to see what happens with a shock to the system. So I'm actually just going to, can I copy and paste here? Dang it. Should have just drawn a damn new one instead of trying to copy and paste and be all fancy. Okay, so here is our economy for computers with our supply and demand curve. In part C, it says, suppose the costs associated with producing a computer decreases. Describe what will happen to the equilibrium price and the equilibrium quantity. So if the costs associated with producing a computer decrease, we're probably going to see more computers starting to enter the market, which means we're likely to see a shift of our supply curve in the rightward direction. So it's likely that our supply is going to increase a little bit. Okay, this increased supply is going to give us a new intersection point with the demand curve, our current demand curve. And it's up to us to interpret what's happening with these new values of Q and P compared to the old equilibrium values, which I'll put here in black. Okay, so our old equilibrium quantity was, what, 12.5? And our old equilibrium price was 5. Okay, so it looks like as our supply increases, the quantity of computers in the market is going to increase as well. And this is going to lead to a lower price for computers. Okay, so I'll say that one more time. So as our supply increases, we're going to see an increase in quantity, right? So we're moving from 12.5 up to some brand new quantity up here. Okay, Q new. And our price is dropping as well. We're dropping from 5 down to some new price point. Okay, so I'll try to summarize that for part C. that should finish up that one. All right, so let me know if you do have any questions about number 3 there. I know that that one's probably, it's a pretty intense question. Trying to interpret those. I know that students typically don't like interpreting those ones. So for those of you that might just be joining in, feel free to email any questions you have to mathquestionshelp@gmail.com, and I'll just kind of work through those questions tonight. I do have to jump over from business math into math 111, math for art students. Just for a second here, I did have a request to work through one question, and that question is, let's see, I just need to jot this down. So it costs $1,900 to manufacture 60 items. And we have a fixed cost of $700. X here is going to represent the number of items that we're going to manufacture, and Y is the cost. And we'd like to find the cost function. That's our question. So for those of you in business math, cost function is our TC function. We actually did this yesterday, didn't we? So good practice for you guys still as well. But for those of you in math 111, we're going to try to tackle this with a linear equation, mx plus b. So our y-intercept in this case represents our fixed costs. So this $700 is my b value, my y-intercept. And what it's doing in the setup is it's trying to give you an actual ordered pair. So it's giving you a particular x value and a particular y value that lie on this line. So I'm going to substitute the 1,900 in as my cost and 60 in as the number of items that have been made here. And so what we can do now is we can try to figure out what the slope of this line is going to equal. First by subtracting 700 from both sides. And then dividing through by 60. Is that 200 or 20? Okay, so the slope of this particular line is going to be 20. So our cost function should look like 20x plus 700. All right, so with that said, it doesn't look like I have any other questions in the inbox to take care of. No particular questions in the chat by the looks of it as well. So if there aren't any kind of final thoughts here in the last couple minutes, I am going to finish up my wine and then sign off for the night. Okay, so remember, business math test is what? It's in class at 11:30, so I do have some office hours in the morning if you have some last minute questions before the test. I'll try to get over to our room a little bit early too as well, just so one, we can get set up for everything, and if you do have some kind of last minute questions, I can answer them there too. Oh, I'm being told to wait a few minutes, so Yeah, feel free to. You can just let me know, Keaton, on show us your house. I'm not taking you on a tour of my house. Not gonna happen. But yeah, if you have any other questions, yeah. So Michaela, I can definitely do 1G. Let me just grab the. Let me just grab that test. What is 1G? Oh yeah, this is kind of a weird one, isn't it? Okay, so back over to that practice test. Let's work through question 1G. It says what the total cost to produce one candle is 45 cents. So that looks like capital C to me. Okay, cost per item. If the price at which a candle sells for is represented by a function, so instead of P being a number like it has been in class, we're going to get a function here. 1 minus 0.02x. And we want to determine the total profit if 10 candles are produced. So we need to figure out our total profit function, what that looks like. Okay, so if I remember correctly, I've only had 1 day of remembrance with this. Total profit is our total revenue minus total cost, but I don't think in this particular question that's going to be helpful. Do we have any fixed costs here? Doesn't look like it. So I think we can go with this formula, price minus cost per item times x plus fixed costs. So let's use that formula instead. And our fixed costs in this particular example, I think they're going to be equal to 0. They're not given. So I'm just going to assume that there are no fixed costs. So let's try throwing in P and C and see what happens. So P is 1 minus 0.02x. C is 0.45. And I need to multiply all of this by x. So this is my total profit function. So let's just expand this out. 1 times x. 0.02x times another x is going to give me an x squared. And then I'm going to have a 0.45x here at the end. So here's my total profit function. Were you guys able to see the spider the last time? I thought I showed it off, but there might have been too much glare with the screen. It's hard to move like an entire laptop over there to show you guys the spider. I can always try to take some pictures and just like remind me. I'll show you in class. I'll show you the pictures. So what do we want to do here? We want to figure out the total profit if 10 candles are produced. So here we're going to sub in x equals 10. Okay, so if 10 candles are produced, our profit should be 10 minus this. So I got a whopping $8 bills. Oh no, wait, that's totally not right. I got a whopping $3.50 actually. Hot damn. I'm gonna sell me some candles. All right, well, I think it might now be time for Denario. I am pretty stoked to have a veggie burger tonight. All right, so if there aren't any kind of final chat questions, I'll stick around for a few minutes. I'll even take a picture of the spider for you guys. Just go through the whole test. There's a solution key, Paul. Come on. Oh, man. She's even moving around tonight. Oh, my God. Yeah, I got a couple good photos, so I'll be able to show you guys. I'll be able to show you guys that tomorrow. So that's awesome. Homemade veggie burger, unfortunately, no. It is. It's the PC veggie burger. It's fucking delicious. Basically. Didn't I give you that? Pretty sure I gave you that test, that one that got printed. All right, guys. Well, good luck studying for the test tomorrow. I will see you all on the other side. Have a lovely night.